my name is Mr. Emil Villanueva, and welcome to General Physics 1.
Today, we're gonna discuss acceleration. Imagine you're in a stationary train, then it moves. What happens to your body? Yes, it tilts. The reason why our body tilts is what we call acceleration. Acceleration is the rate of change of the velocity of an object with respect to time. Change in velocity can be seen by an object slowing down or speeding up. There are times when we have zero acceleration. Let's observe when we have zero acceleration. What can you say about its position? It changes but at a constant rate. Now since the rate is constant, same goes for the velocity. Then the acceleration now is zero. Acceleration in equation form is expressed as acceleration equals final velocity minus initial velocity over time. Let's try an example of a person running. With an initial velocity of 1.55 meters per second, a final velocity of 4.33 meters per second, and it took him 2.88 seconds to reach that final velocity. We have to find the acceleration. Using the equation, we just substitute the given values. We find that the acceleration is 0.965 meters per second squared. Remember to place a square for the unit to avoid confusing this with speed or velocity. How about a different type of problem? Given the values, we now have to find the final velocity. Since we need final velocity, we're going to derive that from our equation by first multiplying both sides by time. Now we need to isolate the final velocity. Move the initial velocity to the left. Finally, rearrange the equation so that it looks properly like this. Now we have an equation for the final velocity. We just need to substitute for the final answer, which is 2.20 meters per second. We can also encounter what we call the uniform accelerated motion. Velocity changes, but at a constant rate. Let's observe a ball starting at rest with an acceleration of positive 2 meters per second squared. Can you tell me the velocity for each time interval? I'll give you time to think. Since we started from rest, the ball at time 0 seconds is 0 meter per second. Next, at 1 second, since we have an acceleration of 2 meters per second squared, the velocity is 2 meters per second. After this, the ball gets faster. Since we have a uniform accelerated motion, this means the ball's velocity will increase again by 2 after a second, making it 4 meters per second. Next is 6 meters per second, and lastly by 8 meters per second. Notice that the velocity will change even if the acceleration is constant. Uniform accelerated motion has 4 equations. One was already shown to you earlier in the video, which was equation number 1, final velocity is equal to initial velocity plus acceleration times time. Equation 2, equation number 3, and equation number 4. Let's have an example. The givens are initial velocity 8 meters per second, displacement 640 meters, time is equal to 40 seconds, and we have to find the acceleration. If we would analyze the equation, which would fit our givens and what to find? Yes, it's equation number 2. Now, if we were to derive an equation for acceleration, we first need to transpose initial velocity times time to the left. Next, we multiply both sides by 2. And to isolate the acceleration, we need to divide both sides by t squared. Now, to make this more visually appealing, let's switch the sides. Substitute. We get 0.40 meter per second squared. Now with the same problem, let's use the acceleration to find the final velocity. The given is the same, except we add the acceleration and we need to find the final velocity. We can solve this problem in two ways, but with either equation number 1 or 3 will give us the same result. So let's try equation number 1. Substitute. Then we get 24 meters per second. How about the equation number 3? Again, we substitute, and we still arrive at 24 meters per second. So our final velocity is 24 meters per second.
I hope you learned something. See you in the next video. Goodbye!